So welcome back everyone to another video on interview questions, and this time we will just a second. This time we will write a function that will return 1 or true if the number is a power of 2, else it returns 0 or false. So we will discuss three methods of achieving that, but first we will use the general approach that you will follow in any high-level programming language, and it is that writing multiple if conditions and dividing the given number continuously by 2. So let's first declare a module and call it test. And then inside the module, I will declare an int variable and let's call it a. Then we will begin with our initial block. And let's assume that the name of the function is power of 2. So we will write an if-else condition that if that function returns true for the variable a, then it will display that it's a power of 2, else it will display that it is not a power of 2. So first we will assign some value to a. Let's assign any value. Let's call it 10. Let's use 10, and let's write an if-else condition, and let's call the function as if power of 2, and let's pass a as an argument. So if it is a power of 2, then it should display the number, and here we will just say the whatever the number is, the number is a power of 2, else I forgot to use $display here, else it will display the opposite. Oh, just a second, I use the $display right here. Sorry, I got confused. So else it should display that the number is not a power of 2. So with our main test body done, let's start with our function. So I will declare my function here, and since that function will have multiple instantiation, it will not retain its previous value. We will use the automatic keyword just to make the function automatic. And if you want to know more about the automatic and static function, just to watch my videos on SystemVerilog functions. So since we will be returning 1 for true and 0 for false, the return type of the function will be bit, and we call the function as is power of 2, and we will pass the value as an argument, and let's call that value a, because a is local in the scope of this test module, so it will not affect it anyways. So first, let's declare, let's say, our temporary variable. Let's call it temp, and we will then perform certain checks. So first, I am using the general software approach, that in which approach we will just divide um, we will continuously divide the given number in the given value, and we will put a couple of, or maybe three, if else condition, and in those if condition we will check whether that number after the division is divisible or even number, and we will also check whether that is not an even number or that is equals to 2. So if after continuous division inside a forever loop, if that function equates to 2, then we will return 1. Otherwise we will return 0. So without any further delay and confusion, I will just begin with my code. So the very first condition should be that if the number here, if the number equals to 2, or if if the number is equals to 2 or number is equals to 1, and both of them are the minimum numbers in the power of 2, where 1 is 2 to the power 0 and 2 is 2 to the power 1. So if that's the case, then we will just return it's true. So this is our initial condition, and if it passes, we will just exit the function and we will return true. And here the display statement, the first display system task, will print its statement, which is the number, let's say 2 in our case, the number 2 is a power of 2, or the number 1 is a power of 2. So if that's the case, it will return the function immediately. And if that's not the case, we will begin with our division. So first, before doing the division, we will just pass the value of a to the temporary variable tmp, which we have declared right here. And right after that, I will start with our forever loop. So it will keep on looping, and in the first statement, at the first line of the forever loop, I will divide our given number by 2. So I will just divide the given number by 2, and I will assign that value back to the variable temp. So my very first condition will be that if the result after the division by 2 is equals to 2, then it's a power of 2. So let's say if it is equals to 2, then we will return 1. And my second if condition will be that if it equals to 0, that it never reached the value of 2. It just got decremented directly to some other value and then to 0. Then it should return false. So that is our function, and there are like lots of discrepancies with this function. So firstly, the problem is that the default radix in SV is decimal. So the answer you will receive will not be in float, it will be in decimal. So let's say if the number is 5, in our case, let's say the number is 5, which is definitely not a power of 2. When it will get divided by 2, we will not get 2.5. Instead, we will get 2. which pass this condition and it will turn out to be true. So there are other means that writing a condition, if else condition, to check whether the particular number is even or not, but still it fails because the default radix is decimal. So we could do separate things like using the float data type, but again, we are using SystemVerilog, and bit manipulation in SystemVerilog is very important. We could play with each and every bits in binary. So there are some better and more efficient ways of achieving the same task. So we will use bit manipulation to check whether the number is a power of 2 or not. So I will just go ahead and delete our entire logic, and then I will use only few lines to write the function. So there are essentially two ways to achieve the same. So let's imagine how would a number look like, a number that is a power of 2 will look like in binary. So let's start with 1. So 1 is, I will write the logic here. So 1 is equals to 2 to the power 0. And how will it look like in binary? It will look like 1, just 1. And let's say our, let me use multiple command lines here. And let's say our next number is 2. And how will it look like in binary? 2 is 2 to the power 1. And in binary, it will look like this, 1, 0. And the next power of 2 is 2 to the power 2 is 4, which will look like something like this. Then we will move to 8, which will look like something like this. And then 16, which is 2 to the power 4, which will look like something like this. So have you noticed a common pattern amongst the values which are power of 2 in binary? The common pattern is that it has only one ones, or a 1 high bit, and the rest of the bits are low or 0. So you just have to do simple bit manipulation using the inbuilt methods provided by SystemVerilog. And the very first method that comes in my mind is count once, $count once. And we will use that to make sure whether that number has exactly a single one or a single bit which is high. And that will confirm that it is a power of 2. So we just have to return that function. So we could just write return, and we will just write $count once, and let's write it inside the bracket. So count once is a inbuilt function of SystemVerilog which returns whether the condition is true or not. So here I will be using the argument, and the argument is a, so I will write a right here. And if the number of ones are only 1, so there are total number of 1 ones, then the function will be true, and the first display statement here inside our initial block of our main test module will print this. And on top of that, I will also need to make sure that the number is not 0, so it's a non-zero number, just for double check. So I will also add a condition that a is not equals to 0. So it's not a 0, because 0 is not a power of 2, of course. So by ending these two condition, it makes sure, and you could see that unlike our general software code, it's a very simple one line code in which we are using our knowledge of bits and we are returning whether the number is power of 2 or not. So without any further delay, let's begin our testing. And here our very first number is 10, which is definitely not a power of 2. So I will go ahead and open the question. So I will compile the code and check for any compilation errors. Okay, we do not have any errors. So let's go ahead and start the simulation. And let's run the simulation. So you could see it right here that it says that the number 10 is not a power of 2, which is the else part of our if-else condition inside the initial block. And it just displays this particular statement. So let's go ahead and change the value to something which is a power of 2. Let's use 16, which is definitely a power of 2. And our function will just check whether it's not 0 and whether it has only a single high digit. If that's the case, then it should return true or the first display system task of this if else condition. So let's compile the code for one more time and let's start the simulation. Okay, so you could see it right here that it says the number 16 is a power of 2. So our function is working correctly as per our intent. So you could just go ahead and check another number, let's say 64, and let's run it again. And it says that the number 64 is a power of 2. So just using the simple knowledge of bits in binary, you could just do some bit manipulation and you could return that bit manipulation as true or false from the function. So other than this, we do have another way which will also return the output that is true or false in a single line, and the function is very smaller for that also. So for that you have to think again. So instead, let's say if in the interview for some reason the interviewer asks you to not to use the to any SystemVerilog inbuilt function like count once, which I have used right here. So still there's a way that you could do the bit manipulation. So let's come back to our the power of 2s in binary. So what will happen if you will subtract a power of 2 by 1? So let's begin with 1. So 1 in binary is 1, as I have mentioned right here. So what will happen if you will subtract 1? What will you get in binary? It's very simple. you get 0. And let's do the same for 2 in binary. So if you will subtract 2 in binary, which is 1 0 by 1, you will simply get 0 1. And let's do the same for 4. If you will subtract 4 in binary with 1, then you will get 0 1 1. Then let's do the same with 8. You will get 0 1 1 1. And let's do the same with 16, which has 5 zeros. And if you subtract it by 1, you will get 0 1. So first I will like to correct an idiotic mistake which I have made right here. 16 has total number of 4 zeros, so it should be 4. And here let's count the 1. Okay, so what will happen? So what is happening? So like our previous example, you could see a common pattern between the power of 2's and their decremented values by 1. So it is nothing, just the all the values getting flipped. You could see it right here that if you will subtract 1 by 1, it is getting flipped or getting opposite or not. And you could see that the value is 0. Same goes for 2, which is 1 0. If you subtract it with 1, you will get a flipped value of 0 1. So all the bits are just getting flipped. Right here also we have our 4 right here, and 4 is in binary. 4 in binary is 1 0 0. And if you subtract it by 1, it will just get all these each and every bits will get flipped. The first the MSB is 0, MSB is 1, which is getting flipped to 0. Then the remaining LSBs are 0 0, which are getting flipped to 1 1. Same goes for 8. It is getting, every bits are getting flipped if you subtract it by 1. And same goes for 16. So we will use that relation in verifying whether this number is a power of 2 or not. So I will do some modifications. So I will just comment this return line right here, and I will write another return. And my very first and the obvious condition will be that a is a non-zero value. And then I will do the AND. So the conditional AND, and after that, since we are assuming that we are not even allowed to use functions like count ones or count bits, so we will just do the direct bit manipulation. We will take the number and we will perform the bitwise AND between the number and its decremented number by 1. So it will be something like this. I will just perform the bitwise. Just a second. And this should be AND, bitwise AND. So you should know what the difference between the conditional the conditional operators and the bitwise operators. So the bitwise operator do the comparison between every bits of both the operands. So here our operands are a and a minus 1. So if if the bitwise and between both the numbers is true, then it will return true or return 1. Sorry, it's 0. So it should be 0, and I will tell you why. So here first, for our very first number, if we will do the bitwise and between 1 and the decremented number of 1 by -1, which is 0, we will get 0, and that is our condition. It should be 0 because every bits differs with each other when we are comparing both the operands. So let's do the same for 2. So if we do 2 with the bitwise operation between 2 and the decremented number, that is 1 for the case of 2. If we do that, we will again get 0. And you will notice the similar kind of bit manipulation pattern with the other numbers. So if we do the bitwise AND operation between 100, which is 4, and between 3, what you will get is again 0. And same goes with 8 and 0, 1, 1, 1, which is 7. And hence and similarly the same goes with 16. Doing the bitwise between 16 and 15. So if you are not allowed to use the count once function, so you could just do this bit manipulation, which will just perform the bitwise, and bitwise happens between every bit. So the MSB of this operand will get compared to the MSB of this operand. Then the second MSB will get compared to the second MSB, and then only it will return true or false. So if that's the case, if we get 0, completely 0, then this will return true. So let's check whether our function works or not. So right now my value is 64, and 64 is of course power of 2. So let's see whether our modification works or not. So I will simulate the code. As you can see it right here, that it is correctly printing that the number 64 is a power of 2. So this is a cool trick of bit manipulation if you are not allowed to use any functions uh, besides your actual function to achieve the same. That is, that particular number, the given number is a power of 2. So let's go ahead and use any other number. Let's say any random number, which is of course not a power of 2. 171. Let's do the everything again. Compile the code, then start the simulation, and then run the simulation. And you could see it right here that it is saying that the number 171 is not a power of 2. So that's all about bit manipulation. I mean, the main motto of this lecture is for you to see the numbers in binary, because that solves a lot of problems. And even for advanced protocols, when you will write the sequences and the test cases, you have to like keep that in mind. You have to remember how you could manipulate the bits. So besides that, these are two easy tricks which you could use if you are asked in interview to write a function to return whether that function is a power of 2 or not. So I hope you find this video useful and stay tuned for more. Thank you so much.